As we discussed previously, there are situations where you must test code directly in the browser, either because you're running scripts from outside the TGML file, or you're seeing unusual results with real data. We're going to look at a few tools and processes here, but to be clear, not all of them will be necessary in all situations. To begin, bindings ultimately read data from devices, but I can't just change a device's value on a whim. Instead, I'll need to simulate some data. To do that, I'll start back at my I/O devices page in Studio. Recall that if the memory column is true, the driver will not attempt to read data from a physical device, but will continue to read the cache. That is, with this setting, I can manually write data into variable tags. To do that, I have some options, but since I'm only testing a single value, the simplest is a user input write operation component. I'll drag one out and tie it to the item to be written. Let's say A phase current on the utility main. I'll set my rectangle binding to the same point. Finally, inside my script, I'll add the keyword debugger. We'll see what this does soon. We already know that the code works because we've thoroughly tested it before. But what if this was something new? For that, most web browsers today will have some sort of built-in development tools. In Microsoft Edge, these are found in the menu under More Tools, Developer Tools. But other browsers have similar features. I'm not going to walk you through all the tools here, but there are a couple of features and tricks related to power operation that you should be aware of. The Console tab has two purposes. Just like the console window in preview mode, any messages generated by JavaScript are displayed here. In addition, we can run code directly at the bottom. This is a simple method to call and troubleshoot functions. Additionally, we have the Sources tab. This will attempt to create a tree of page sources on the left to navigate, and while our custom scripts are buried here, they're easier to find manually. I'll select Options, Open File, and setpointscript.js will be available. This isn't just a viewer. I can make changes to the file, save, and they'll be run immediately in the browser. Just remember that this does not save back to the file system. If you want to keep your changes, you'll need to copy them out and save them in the file editor. Finally, the Network tab monitors communications between the page and the web server. I can stop recording with the top left button and check what has transpired. There are two page requests I see being made over and over: counts and read data points. If I click on read data points, the header indicates this is an HTTP post request meaning we're going to send some data to the server. The Payload tab shows me this is the list of bindings being read on the page. If the page had more points, this would be a much longer list. The Preview tab contains the response from the server, including the exact value being returned. I can use this information to ensure I'm reading the correct item from the server. Let's put these to use. On the page, I'll change the value. And the Sources tab will automatically jump to my code and execution will stop. In the console, I can check evt.getValue to verify the value coming across, or run any other methods needed to debug the code. I can also step through functions to verify they are setting the right values, just like any other code debugger. These are the tools available for creating and testing our customized scripted graphics, and you'll use them heavily because the code rarely works perfectly the first time. Now that we have the basic concepts covered, let's look at some real examples of JavaScript and graphics. Until then, thank you.